On this episode, the governors come off. We are going to test the Harbor Freight Predator and the Lifan with their governors removed against this race-ready clone. We are excited to get this BSP 212cc displacement engine onto our dyno because on paper, this is a much better engine compared to the Lifan or the Predator. When you buy one of these race spec clones, some assembly will be required. None of these engines ship with flywheels because the factory cast iron flywheels have been known to come apart at higher RPMs and are extremely dangerous to use. The Dakar seen here is the least complete, missing both the flywheel and cam. So this is a good candidate for a modified engine where the cam will be replaced anyway. We'll be testing our 196cc clones versus the 212cc versions on a future episode to see how much the 2mm difference in bore really matters. Today we will focus on the 212cc displacement clones. This BSP 212cc is what we think will establish the power benchmark in stock configuration. This engine has the JT223 head, the best flowing stock spec head, and the BSP 4 camshaft that has a modified cam centerline helping the engine to rev higher. With this combination, we would be surprised if it wasn't the power leader. We are going to get the Predator and Lifan stripped down, tanks and governors removed, and all engines will receive aluminum flywheels for safety. We are using our dyno fuel supply so all the tanks were removed, and as we push the bounds of these engines, we didn't want the fuel on the engine itself. Besides, we think these engines just look cooler without the bulky tank. The external governor mechanisms were removed, and we will be directly driving the throttle during our dyno testing. As mentioned in episode 1, the new Hemi head Predator has small differences compared to typical clones, and the flywheel is one of them. The Hemi Predator uses a bigger crank taper, so make sure you get the correct flywheel if you're using a Hemi Predator crank in your build. We also removed the factory air cleaners and exhaust systems, fitting all the engines with the same air filter adapter and straight pipe. Let's get these engines on the dyno and see how they stack up. The first engine off the dyno was the Predator. With the governor removed, this engine revved higher up to almost 5,000 RPM. Comparing to the stock configuration, we did lose some torque, but it looks like the trade-off was well worth the horsepower gained. Most aftermarket flywheels come with more timing advance. We ran 32 degrees of advance with this configuration, losing some of that low-end torque. The Predator made 11.2 pound-feet of torque at 3,300 RPM, and 8.6 horsepower at 4,600 RPM. A loss of 0.3 pound-feet of torque, but a gain of 1.8 horsepower. Overall, the cost of this engine was $240 or $28 per horsepower. Next on test, the Lifan. We ran the same configuration on the Lifan. Governor removed, 32 degrees of advance, straight pipe, and air horn. Notice the very flat torque curve and the loss of torque over the stock configuration. This is a great example of how throwing parts at something does not always make it better. It looks like the Lifan is not happy with this combination. We typically see these engines go lean when we free up the intake and exhaust, and we'll later instrument this engine to figure out what is causing the issue. Definitely more work to be done on this engine. The Lifan made 9.3 pound-feet of torque at 2,800 RPM and 8.1 horsepower at 5,500 RPM. A loss of 1.8 pound-feet of torque, but a gain of 1.1 horsepower. Our overall cost for this engine was $301 or $37 per horsepower. Next on test, the BSP. The BSP didn't disappoint. The BSP revved out to almost 5,000 RPM, but more importantly, notice the amount of torque this engine made. This engine killed the competition in torque. One important note, this engine ran the least amount of timing advance at 24 degrees. The BSP made 13 pound-feet of torque at 3,250 RPM and 9.1 horsepower at 4,900 RPM, outperforming the Predator by 1.8 pound-feet of torque and a half a horsepower. Our overall cost for this engine was $286 or $31 per horsepower. This is a fun and interesting set of tests, with the Lifan giving us an important lesson. Speed parts do not always mean an improvement. Everything needs to work together. Our goal of this episode was to show how you can get the most power with inexpensive, easy modifications and without cracking open the engine. We will get into high performance builds later. However, we'll continue first to see how much power we can get out of the simple modifications before we turn the engine internals. The BSP definitely shined. It has an impressive torque curve and made some major power numbers. And in our opinion, is the best inexpensive engine option in stock configuration.